The ceiling is cracking. Not a hairline crack. A crack you can put your finger inside. Running from the corner of the window frame across the ceiling to the wall junction. Growing. You called the building authority 6 months ago. They sent a form. You filled the form. You heard nothing. The crack grew. You called again. They sent another form. Outside the window the temperature drops to -18 tonight. The crack is not insulated. The cold is coming through it. Modern people in this situation have 2 options. Pay a professional or wait for someone else to fix it. Behind the Iron Curtain, both of those options were frequently unavailable simultaneously. The Soviet state built tens of millions of apartment units, the Khrushchevka, the Brezhnevka, the standardized concrete panel blocks that defined the visual landscape of the Eastern Bloc, and then systematically underfunded their maintenance. Repair crews existed on paper. Their actual visit schedules did not match the paper. Maintenance budgets were allocated in the plan and consumed elsewhere. The buildings deteriorated, and the people who lived in them fixed them. Not with purchased materials from a hardware store. With what was available, clay mixed with horsehair and straw, the same plaster composition that had kept buildings standing for 3,000 years before Portland cement existed. Pine, resin and coal tar mixed to a waterproof sealant that cost nothing and lasted decades. Newspaper soaked in paste and layered over cracked surfaces, the cheapest crack filler in the history of construction. Broken glass, gravel, and ash packed into gaps that let the cold through. Sand, lime, and water reworked into mortar that matched the original joint material of walls built 50 years earlier. Stay with me, because number 4 on this list is the most structurally significant, zero-cost building repair method ever practiced in Soviet-era housing, a technique that stabilized cracked and spalling concrete using materials found in any household, required no professional training, and is still visibly holding buildings together in former Soviet bloc countries today. Let's begin. Number 1. The clay and fiber plaster system. Clay plaster is the oldest continuous building material in human history. Not because it was the best option available. Because, for most of human history, it was the only option available. And because it works. The basic formulation, clay subsoil, not topsoil, which contains organic matter that will rot, mixed with a fiber reinforcement and water to a workable consistency. Applied to any wall surface in layers, each layer allowed to dry before the next is applied. The fiber reinforcement is critical. Clay alone dries hard but brittle, prone to cracking as it shrinks during drying. Fiber extends across the crack planes as they form and holds the matrix together. The traditional reinforcement materials were animal hair, horsehair, cattle hair, goat hair, mixed into the clay at approximately 5% by volume. The hair fibers distributed through the matrix bridge shrinkage cracks and hold the plaster together through temperature and humidity cycling. Behind the Iron Curtain, where the state maintenance system had failed to replaster walls in decades, and where water infiltration through failed exterior plaster was destroying interior finishes and creating conditions for structural deterioration. Apartment residents replastered using clay dug from any available site, construction, excavations, riverbanks, the soil exposed by any earthworks project, and fiber sourced from any available waste material. Animal hair, when available. Straw chopped fine when not. Shredded newspaper as a last resort, not as effective as natural fiber, but functional for interior applications where moisture exposure is limited. The plaster was applied in 3 coats. A rough scratch coat, keyed into the underlying surface by scoring or by tying wire mesh over severe deterioration. A leveling coat, applied when the scratch coat had dried to leather-hard consistency. A finish coat, thinned to allow the surface to be worked smooth with a damp cloth. The result was a wall surface that breathed, exchanging moisture vapor with the interior environment rather than trapping moisture behind an impermeable surface, and that could be repaired by anyone with a bucket of clay and an afternoon. No professional, no purchased material, no special tools. Soviet apartment dwellers who maintained their walls with clay plaster were practicing a building technique validated by thousands of years of use across every climate and culture where clay subsoil was available, which is everywhere. Number 2. The tar and resin waterproofing system. Water destroys buildings, not quickly, not dramatically, slowly, systematically, invisibly. Water infiltrating through cracks, through failed joints, through deteriorated roof surfaces, into the structural substrate where freeze-thaw cycling expands it and breaks down the concrete or masonry from within. The Soviet concrete panel construction system was particularly vulnerable. The joints between panels, where sections of prefabricated concrete were assembled on site, were sealed with materials that degraded over time. As the seals failed, water entered the panel joints. Freeze-thaw damage proceeded. The joints widened. More water entered. The state maintenance system was supposed to reseal these joints on a regular schedule. It did not. Soviet residents resealed them with pine resin, collected from any pine tree, the amber-colored exudate that bleeds from any wound in the bark, melted over low heat, and combined with cold tar or bitumen salvaged from road repair sites or construction waste. The resulting mixture, applied hot to cracked and open joints, penetrated the irregular surface of weathered concrete, filled the void, and set to a flexible, waterproof seal that bonded to the concrete surface and accommodated the thermal movement of the building. The coal tar component is carcinogenic and must be handled with care. Soviet maintenance workers handled it with the care that a person handles something they need in the absence of anything safer. Carefully, with minimal skin contact, with adequate ventilation. The health considerations are real. The waterproofing effectiveness is also real. For roof surfaces, the flat or shallow-pitched roofs of Soviet-era construction that were universally prone to leaking hot-applied tar and resin was the standard repair medium. Applied with a brush or a spreader to the deteriorated felt or membrane surface, it restored waterproofing for years at a time. Pine resin from the forest. Coal tar from any road or construction site. Both available at zero cost. Both functional. The building stayed dry. Number 3. The newspaper and paste crack filling system. This is the method that will make engineers in the comments uncomfortable, because it is not structural. It does not restore load-bearing capacity. It does not arrest underlying deterioration. But for the specific problem of cold infiltration through non-structural surface cracks, the hairline cracks and minor gaps that cover the interior surfaces of any aging building and allow cold air to circulate through wall assemblies, it is a remarkably effective solution. Newspaper soaked in a paste of flour and water, or in any available adhesive, including diluted animal glue, starch paste, or any adhesive that can be prepared from common household materials, applied in layers over cracked surfaces, creates a paper match repair that seals the surface crack, insulates the void below with layers of trapped air in the paper fiber, and can be painted, whitewashed, or plastered over to produce a finished surface. Soviet apartment dwellers applied this technique to every cracked surface in their homes as a routine winter preparation measure, not as a permanent repair. As an annual maintenance operation that kept the cold out through the heating season and was renewed each autumn. The technique also applied to window frame gaps, the spaces between the window frame and the surrounding wall that develop as buildings settle, and thermal cycling causes differential movement between dissimilar materials. These gaps, often reaching 1 to 2 centimeters in width in older Soviet construction, were the primary route of cold air infiltration into apartments. Packed with rolled newspaper strips, sealed over with paste-soaked paper, and whitewashed smooth, the gap was invisible. The infiltration was stopped. The apartment was warmer. The total material cost, nothing. The newspapers were read first. Stop here. Look at your home right now. Think about every crack, every gap, every failed seal, every deteriorated surface. Now think about what it would cost to have a professional repair each one. For most people, the answer runs to several $1,000s. For many people, it runs to more. Now think about what the Soviet apartment resident did with clay from a riverbank, pine resin from a tree, a newspaper from yesterday's stack. The same problems, different tools, different cost. Write in the comments, what is the worst repair problem in your home that you have been putting off because of the cost? Number 4. The lime mortar repointing system. This is the structurally significant one. Masonry buildings constructed from brick, stone, or concrete block, bonded with mortar, depend on the integrity of the mortar joints for their structural coherence. When mortar deteriorates through weathering, through chemical attack, through freeze-thaw cycling, the joints open, water enters. The rate of deterioration accelerates. The masonry begins to move. Behind the iron curtain, the brick and stone construction of older buildings, those predating the concrete panel era, received no systematic maintenance during the Soviet period. The mortar joints of buildings constructed in the 19th century deteriorated through 40 years of neglect. The residents of these buildings repointed them, using lime mortar, the same material that the original builders had used, prepared from the same materials using the same process. Lime putty calcium hydroxide produced by slaking quicklime with water mixed with clean sharp sand in the traditional proportions of 1 part lime to 3 parts sand, worked to a stiff but workable consistency. Applied to the raked-out deteriorated joint with any tool narrow enough to reach the joint depth. Tooled smooth at the surface to match the original joint profile. Kept damp for several days to allow proper carbonation, the process by which lime mortar gains strength through reaction with atmospheric carbon dioxide. Lime mortar has specific advantages over modern Portland cement-based mortar for repointing historic masonry. It is softer than Portland cement and accommodates the thermal and moisture movement of older masonry without cracking. It is permeable to moisture vapor, allowing the wall assembly to breathe. And critically, it can be sourced from agricultural lime, the same calcium hydroxide used for soil amendment and disinfection, available at any farm supply in bulk at minimal cost. Soviet residents who repointed their buildings with lime mortar were preserving the structural integrity of buildings that the state had abandoned to deterioration. The lime cost almost nothing. The sand came from any source. The labor was their own. The buildings are still standing. Number 5. The thermal bridge elimination system. In any building, heat moves from warm to cold through any available path. Thermal bridges, uninsulated structural connections between the interior and exterior, bypass engineered insulation and allow heat to escape at dramatically elevated rates. In Soviet-era panel construction, thermal bridges were structural features. The concrete floor slabs and wall panel connection points penetrated the building envelope at every junction, conducting heat directly from interior to exterior. The residents could not remove the structural elements. They could insulate around them. Any material with low thermal conductivity fitted against cold surfaces was applied to known thermal bridge locations. Cork salvaged from bottle corks, thick felt cut from worn clothing, compressed straw mats, salvaged wood boards at floor wall junctions, Rugs hung against cold walls, not for decoration, but for thermal performance. The specific technique for the coldest corners, where two exterior walls meet, and the concrete structure creates a severe thermal bridge, producing condensation and mold, was a built-up insulation pouch constructed from layered fabric, filled with sawdust, dried plant material, or cotton batting from worn mattresses, fixed against the corner surface. Inelegant, effective, available to anyone with fabric scraps, and 15 minutes. Modern thermal bridge products cost hundreds of dollars per square meter installed. Soviet apartment residents used a sawdust bag nailed to a corner. Their condensation stopped. Their corners dried out. Their fuel consumption dropped. Here is what all of this means. The modern construction industry has produced a relationship between people and their buildings entirely characterized by dependency. Buildings fail. Professionals repair them. Materials are purchased. Systems are replaced. This dependency is so complete that most modern people have no idea what their building is made of, or what would be required to maintain it if professional services became unavailable. Behind the Iron Curtain, every person in a deteriorating apartment block understood their building as a material system they were responsible for maintaining, not because they wanted to, because no one else was going to. Clay plaster on the wall, tar seal on the roof, newspaper in the window gap, lime mortar in the brick joint, sawdust bag in the cold corner. None required professional training. None required purchased materials. All of them worked. The buildings Soviet residents maintained with these techniques are still standing, 50, 60, 70 years later. Some of the buildings the state was supposed to maintain, but didn't, are not. Your home is a material system. It will deteriorate if unmet. The question is whether you understand it well enough to maintain it yourself. Start with the worst crack. Clay, fiber, water. That is where every great building repair tradition in human history has started.